Welcome to the first video of why the Earth is a geoid. In this episode, I'll be teaching you why the Earth is a geoid. So let's begin. Have you ever wondered about the force known as centrifugal force? Well, if you don't know, I'll be teaching you. Let's begin. So let's take a walk in the park. Now let's get on the merry-go-round. Now spin it. What is that mystical force that pulls you away? That force is known as centrifugal force. Centrifugal force is the force that pulls you away from the center of rotation. So, if you take the Earth as a merry-go-round, if you're on the equator, then you would be flying out. You would be actually flung out. Believe that, but sadly, gravity is much more stronger than the centrifugal force of the Earth. So, if the Earth was spinning really fast, gravity might even lose its control and we'll be flung out into space. Weird. So now let's begin. Why is the Earth a geoid? It's a geoid because of centrifugal force. Now, we assumed the Earth was a merry-go-round. That can actually be assumed in real life. So, the equator is far away from the North Pole and thus it moves more than the North Pole. Rotational motion, all parts of the sphere or the object do not move the same distances in the same intervals of time. So, the equator moves more distance than the North Pole. North Pole almost doesn't move at all. It doesn't move at all, except due to revolution. So, if the equator moves much more faster, it means the centrifugal force is greater at the equator, pulling you out. But as it pulls you out, it pulls the Earth out too. So if this is the sphere rotating, Earth seems to be pulling it apart and apart, but Earth is a solid, so it feels harder. But what is under the Earth? I mean, what is under the crust of the Earth? Our modern day Earth. I'm standing on Earth. No, you're standing on Earth, but you're standing on the crust of the Earth. So, what is under the crust? Under the crust is liquid magma, molten rock. Now, if you take a glass of water and cover the lid and place it on a merry-go-round and tape the lid to the glass and spin the merry-go-round, oh, forgot. Tape the glass to the merry-go-round or the glass is going to spray in your face. So, put the glass on the merry-go-round, tape it, and the water inside will begin to act strangely once you start spinning the merry-go-round. So you spin the merry-go-round, the water is going to be like pushed out. So if this is the glass, and you put it on the merry-go-round, while it starts spinning, the water will always be facing the other way, the way which is away from the center. So once it's spinning, the water is going to be at this side, pointing this side. And when it comes here, it's going to point this side. Then it's going to point that side, and that side, and that side, that side, that side, that side, that side, that side, that side. The water will never touch the inner part of the circle. This is because of centrifugal force. Now the same thing applies to the Earth. The magma in the Earth pushes out. It doesn't want to be near the center. So it's more maximum influence on the equator. So the magma is pushed out, pushing the crust out and out and out. But matter just can't come from anywhere. The Earth can't just feel like this and become bigger and bigger and bigger and bigger. No. While this becomes larger, this becomes smaller and smaller and smaller and smaller. So you might even think the Earth is going to be a flat thing like this in the future. But that won't happen because rotation is going to bring it back to this. So it might remain like this forever and forever. But it will never go like this. And the Earth is a sphere, not a disc. Otherwise we'll be flying off the edge every single time. So, now that you know why the Earth is a sphere, I mean, why the Earth is a geoid, go to the second video where I'll be telling you why your weight decreases as you go up and up and up to the North Pole. And as always, thanks for watching.